two important points that we mentioned here. The first thing, to find the R Thevenin, we cannot use parallel or series. I have to put it Thevenin equivalent because I need one single resistance connected with the my capacitors. So we need to remove the entire part, connect with the capacitors, and just replace it by voltage source and series with the R Thevenin. The second part, when I have independent source, I cannot get rid of from it to find the R Thevenin. I have to go through the path R Thevenin equal V open circuit divided by I short circuit. Now we find V out or the V1. Now we already have the formula for the I short circuit. Can you calculate for me? I short circuit, it will be minus 5.4 volt divided by 20 kilo ohms. How much this one? By milliamps. So just 5.4 divided by 2, 27 milliamp. Confirm that, guys. Yeah, 27 times 2, 45. Yeah, this one is milliamps. Now we can find our R Thevenin. In that case, with I short circuit, oh sorry, V open circuit. V open circuit divided by I short circuit. Eric, anything?
The I short circuit should be 0.27 milliamps.
0.27.
Yeah.
Here is 0.27. Yes, 4. Yeah, 20 here. Yeah.
That's what I got too.
Yeah. So here is the minus 0.27 milliamps. Now I have minus 5.4 volt divided by minus 0.27 milliamps. Equal how much?
Negative 20.
You cannot get negative. We have negative 5.4, negative 0.27. So it should be positive.
Oh, negative. It's just 20.
20K.
20.
Another note, guys. Look what we have here. We have the R Thevenin. When we find the V open circuit divide I short circuit, I end up with the positive value. Positive value means, what that means? My circuit is stable. But it doesn't mean it's not gonna be end up with the negative sign. So if you end up with the R Thevenin negative sign, which the only case when you have dependent source or op amp in your circuit. That's the only case you may get negative resistance. When you get negative resistance, the only interpretation for that, the circuit, it is unstable. Okay. Now, what we can do, we can go back to find our formula, right? So we need to find the R tau or time constant, R Thevenin times C. R Thevenin, we just calculate 20K times C. How much C? 5 micro, 5 power to the minus 6 farad. Calculate it for me. Then we can find our V capacitor of T, which formula again, V open circuit plus V initial conditions minus V open circuit exponential is minus T over tau. We have everything that we need. We have V open circuit, we have initial conditions, we have tau. Okay, so you can do it. Just to save time for a second example. Question with that? It has any question? Okay. Move second example, because this one is second example may be confusing, but you need to just to follow certain steps. You will be totally fine. Here's an example here, what we call the megaphone. When you use this speaker to protest or something, we use the megaphone to amplify the voice. And just kind of you can represent this megaphone as this simple circuit, resistors and inductors with another your output in the microphone. This microphone and speaker both. Now the only thing Vs here was what your input, basically your voice. The B or the guy who gonna speak loud, this one. So that's the signal here. Usually if you speak normally for the human being from 0.3 hertz to 3.4 kilohertz. That's the voice it can be heard from the human being when you are speaking normally. That's the range. So here, this is what we given for the speech. It is magnitude is 10, and frequency here is the 100 T, which radius this case. So divide this one by 2 pi, you end up with the 15 hertz. So we are in the range of the heard voice. And here is just an example, but what we are dealing here, we have the electrical circuit, and as a model for my megaphone, represent my voice with the two resistors with the inductors. And we need to find what the output comes from my microphone here, how it looks like. The starting point here is the same thing. So we with our functions here, the volt, it should be based on natural response plus forced response. All the time, forced natural response, exponential part. Time is a certain magnitude. So in this case here, this is my term, entire this one. This is the natural response, which basically I can type it E us minus T over tau. This is the natural response. Whereas the A here right now represent AZ or V0 minus V open circuit. So all the time natural response, that's how I represent. Forced response is dependent about my input signal. In this case, I have the input signal represent as a sine wave. The sine wave, it has a kind of the tricky one. So you have to stick with the certain formula that we listed in the first table. So now let's start. The first one, we're gonna do it. What happened with the signal before the t equals 0? What does that mean? Because I have u of t here, means my sinusoidal wave is starting at t equals 0. So what happened at t equals 0? What the voltage V looks like. Okay. That's our first step. We're gonna start with it. So what we're gonna do, guys? Basically, we are looking for volt, not the current. Let's see. Here we have one single current because we have the capacitor, we have the inductors. So basically, in the inductor, considered about the current, not about the volt. Here is the IL, we can call it, or I. And remember, guys, we ask to find V, not I. Volt. So what I can do? So the first step, let's find our Kirchhoff voltage law. I write down my equations with all the elements that we have. We're gonna apply the Kirchhoff voltage law. Start from this part here. Somebody help me with that. I'm gonna start from the VS. Who can do it?
Negative Vs.
Negative Vs. Plus
1 ohm times IL.
1 ohms times I. Let's call it I capital, guys, just to make it easy for me to write it down. I. Where is the I equal IL? So let's type it here. I equal IL of t. So don't confuse. If I type I mean the I of IL. Okay. Next. Next. We're looking for the current through the inductors, right?
Yeah.
Okay.
Is that L times the derivative of
I of L equal, I think 1 of L.
oh yeah,
Am I right?
no, I think it's the integral of the voltage.
Oh, I switch it. Sorry. Sorry. We are looking for the VL. This one should be L di by dt. You agree with that?
Yeah.
Okay. Okay. So let's type it here for simplicity. Let's type it VL. Then we can see it later. VL. Next. Plus. Sorry, here's the plus. No negative. Plus what?
V.
Vs or V. That's what I am looking for. V of t. The entire theorem equals 0. If you look at my formula here, I have VL, which basically I'm talking about the IL. I have V. So I try to just to make simple, you can say change, but very easy and logic thing we can do it. First one, the current that I have is the current through the one single loop, right?
Yeah.
Can I claim the my IL for if, again, when it's talking about the t larger than 0 or less than 0, steady state, right? Steady state, that means stay for a long time. Steady state, what that mean? How can I represent the inductors? Short circuit, right? Capacitor open circuit, inductor short circuit. So basically the current I of t, if you can complete as can I represent by second now let's think it about different way. Yes, let's write down the voltage equations. V we know the VE or the V of t here equal IL or I, let's stick with the one form, I times what? Times 8 ohm. Am I right? I have the current here, IL, it's the same current through the 8, and the voltage here, V of t, it's the volts across 8 ohms only. Ohms law, current, and I have the resistance. Right? We can simplify it by just I equal V of t divided by 8. Now I have a derivative. I wanted to see it like this case. What I can do. I don't have I, but I have exactly, guys, if you have, for example, what I can say. X equal to Y and ask you to find the derivative for both parts. So you told me it's the d by dt x equals to is constant, d by dt y. So here's the 8 is constant. So if I just make a derivative, so I can claim this one di by dt equal 1/8, because constant, times d by dt v of t. You agree with that? I did nothing, just from these equations here. I just tried to find the relation between IL and V across the 8 resistors.
You basically just substituted the I into the VL equation, right?
I don't do that yet. I just make a derivative for the current here for 2 parts, exactly like this case.
Okay.
Now I can formulate it, because to get the VL, I need to times by L, right?
Yeah.
So from here, from these equations here, you can find dl or di by dt. Basically what? It is 1/L times V. I typed correctly, don't have space for that. So here's my VL right now. I'm looking for VL. This one I by dt. So I have here is the I by dt. So now times by L, guys. L times di, this equation again, di by dt equal L times 1/8 dV by dt. Everybody agree with me? So basically what we have, this part here is VL. So L divided by 8 dV by dt. Question with that? So now basically what we have, Vs, okay, which that had this value, I, which the IL, VL, I have a relation between V and I, which is supposed to be this one. So what I'm gonna do, I'm gonna replace all the I and VL and replace it by V. So I end up with the one equations, Vs and just V, because I'm looking to find V, not I. So again, to write down our equations here, the final formula here, and I hope I did it in the right way. So we end up with the 2 divided by 8. Let's write down. Here is the dV by dt. And this one is the equal I times 1. So this one is the sine 100t. And minus 9 divided by 8 V of t. So what I formulated here, differential equations. If you want to just to write it down as the way that we started this chapter, dV by dt plus 9 divided by 8 V of t equal 10 sine 100t. Now this is my first derivative equations. Now from here, I can find my x of t, which basically Vn plus Vf. So how we can find it? First one, Vn. Vn, as we mentioned, constant times exponential t divided by tau. Now, from these questions, I need A and I need tau. Usually, A is the last part you can find it, but tau we can find from our circuit here, guys. How much that R? Tau, this is the formula for the L divided by RT. And two resistors in series, I have 1/2 divided by or times 1 plus 8 ohms. You end up with the 1/18. And this one's L, it is half, so that's what 2 come from. Times R total Thevenin, 1 ohms plus 8 ohms, 1/18. So I have the tau. So for the A, so we're gonna stop right now for the A. Keep it as it is. We can find it later. Now the second part, we need to find, that's the maybe confusing part. We need to find the VF. VF, in that case, we have the sine wave. So in the sine wave case, I have to assume my output should be sine and cosine term with the constant B cosine. How much? The same frequency, the same radiance. 100t plus sine term, a constant with sine term with the same radiance. Sine 100t. That's my VF. So now how I can find those values? How I can find A and C? So you go to this equation, this is called equation number 3. Okay, and we take that. Here's the change this one for that. This one 1/4 dVF divided by dt plus 9 divided by 8 VF of t equal my terms as it is, sine 100t. So what I gonna do? I have to go to the VF, find the first derivative, plus 9/8 times my original signal. Okay, I think I did it here. I did it. Let me see part of it. It's confused me more than what they gave it to me. Okay, let's find dF here, dV by dt. What the differentiation of the cosine? It's minus sine, right? So here's gonna be minus sine, and then differentiation inside the cosine, 100, right? So here's the minus b, or minus 100b, and this term will be sine 100t plus the same thing, and here's the c and sine should be 100c, and this one cosine 100t. Okay, and then we have the second term. You add this one for the you times this one by 1/4. So basically we have 25 and 25. This is the first part. The second part will be 9/8 times VF, and then you add component cosine together and sine together. You know how you can do it, but probably we need to add more more slide or to give you still have time. I don't have more time, but yes, I will show you the final formula that I got. The final formula that I got two equations: 100C plus 18B equals 0 because I don't have cosine theorem. This one's the cosine theorem for both. And the second equation is here minus 100B plus 18C equal 160. Where come 160? This one, guys. This part, because we're gonna just simplify it by 8. I have 8 here and 8 here and 80, and then multiply by 2. Okay. And the second one, here is the sine minus 100B, cosine part 100C. So you find here's 100C comes from the cosine part. And from here we can find this 2B equal minus 1.5, C equal 0.279. Now I go back for my form. Sorry, I know this one is the long. I cannot finish it, but I will do it very quickly and show you something with the MATLAB. VF. And we have A, EUS minus 18T plus we have minus 1.55. This is the theorem of cosine 100T plus 0.279 sine 100T. So now the only thing missing here, A, so it's basically we find by V of 0. V of 0, we have what the volts across the 8 volt or the 8 ohms. What we end up, here's the equation that you remember, guys. 8 plus time V of T equal 8 with the resistor is 8 times I of T. So when we have T equals 0, and this one will be 0. So basically I end up with the 0. 0 here will be A, 0 here will be minus 0.15, and 0 for the sine will be 0. So you end up with the A equal 1.55 positive. Why not good, Allah? Oh, suddenly I found you're disconnected, guys. Sorry. Okay, I want to show you something with the MATLAB. Really, here is the. Where is the? I'm done with that. Oh, I hope it saved it. My work. So that my computer suddenly make updated without my permission, really. I will hold you for 5 minutes, guys. The formula that we end up, I wanna spend the time to finish it, but the final equation that we find it, VF, just give me 1 minute, not more than 5 minutes for that. V of T, we find the A is 1.55, E is minus 18T minus 1.55.
Professor,
Go ahead.
we can't see your screen.
Oh, sorry. I don't share you with you, so that's why I didn't see it. Where is my work right now? Just write down what we end up. I will repeat it again and type it in the good way. But this is the final formula that we got. Cosine 100t plus 0.279 sine 100t. Let's talk about this one first, very quickly. Here is the natural response. We're gonna be disappear with the time. What's gonna be stay for a long time is cosine and sine term. Let's see how it in the MATLAB. See how it looks like. Can you look at the MATLAB code? Can you see the code, right? So the first one here is can you see it?
Yes.
Okay. So here is our total R Thevenin. So 1 ohms plus 8. Those two series resistance that I have. And the L I have 0.5. Here is the tau. L divided by R totals. And I set the time. And here is my constant A and B and C. My natural response would be just basically A exponential T divided by tau. My first response, B with the cosine 100t, and C with sine of t. My complete response, initial plus final, and then I want to drop all of them in this, or the plot all of them in the same curve to see what happened with the natural, with the force, and with the total. Still you can see it? Okay, so here is the natural response. What we expected exponential part, so it should be disappear at least 5 tau, or 5 times tau. Okay, that's the natural response. For the forced response, it is totally sinusoidal wave, even if it is just combination between sine and cosine, but the magnitude, it should be constant as it is. It's the sine wave. It's the forced. Now, when you combine those forced and natural response, basically just you add those two together. So you see the amplitude is a little bit high, and then we get slower, until the natural response will be disappear. And then I go back for the same value, the same signal here. So the permanent one, forced response, natural response will be disappear at a short time. Okay. Question with that? Do you have a minute to just help you for the quiz one? Give me 2 minutes. I will explain it to you very quickly. I'm sure you can get it. I'll at least submitted your work, no matter what you have done before 1 o'clock, whatever you have done. But let's see what do we have, and very quickly, guys. So the first one asks you for the VC of T, voltage as a complete response. So the first one, U of T, so we're gonna go to the T less than 0, because U of T here. And since my current source is equal 0 before T of 0. So basically what do I have? I have this one open circuit, and the capacitor will be open circuit as well. You agree with that? So I don't have source. So basically VO equals 0. Because of U of T, guys. That's the reason. There is no voltage or no source before equals 0. The second part, just your input signals will be this current here. So basically sine and cosine response. What you need to do, you need to write down your equations. Here is the current. The current here equal the current, this one here, and the current go this way here. Or you can use Kirchhoff voltage law. So either way, so let me write down very quickly for you. Here is the minus 10 cosine 2t plus 15 1 over C dV by dt. Where is the C? We have theory, right? So C dv by dt. The current across the capacitors. A 15 comes from the R. Okay. Plus VC of T. So if you want to just rewrite it again, so you end up by the dVC by dt plus 2VC and this part will be 20 cosine 2t. So basically that's what you have. Now the only thing now you're asking for VF, it should be, you can assume any constant, cosine 2t plus C sine 2t. And you need to find the V by D, or find dF, or the first derivative, by make differentiation this one and plug it here, plus times the same V of C, this one, equal to cosine or 20 cosine 2t. Then you just compare two values, the parameters for the cosine together, parameter for the sine together. Okay. And when you need to find your natural response, the same thing. Here is the VC again, A is minus T over tau. And just you need to find V of 0 equals 0 in that case to find A. But this one you have to plug it with this formula here. I type here VC, guys, not VN. Here is the VN. Here is the VF. Here is the VC. So it will be equal VF of T plus, or vice versa. So when I'm looking for the initial conditions 0, I'm looking for VC 0, which initial condition that we start from here. I have voltage across the capacitors equal 0 initially because I don't have source. And this one will be VF of 0 plus VN of 0. That's to find A. Where is the A? Is the natural response. The VN equal A E is minus T over tau. To find B and C, you go to this equations here and you plug your parameters. First derivative plus times VF equal cosine. You end up with the two unknown, two equations. You can find A and B first, or B and C first. Then finalize your equations, this formula here, and find A. Then you write your equation. It should be your equation like that. Your final equation should be like that. One natural response exponential term. Second, it is cosine and cosine. The only thing you need to focus what those values, this constant and this constant. Sorry to hold you guys more than what I expected. No matter what you have done in this circuit here, you submit your work and you will get rewarded. Okay. But without submission, you get 0, but you have to submit it.
So is this graded?
Yeah. This is kind of the quiz I give you, kind of the bonus. So I supposed to be start with you to solve it and just let you finish it. And then you submit it. But since the time is not valid with us, that's the main idea. So you're looking for the B and C and A and find those values. And go to the test and quizzes, you find the quiz number 4. You submit it, guys. I think I set it to the 1 o'clock or something.
Professor, I have a real quick question. On the quiz, it says example 3. So are you changing it to example 2 now?
Yeah. This is no this example 3. I already solved 2 examples before, right? Yeah, 2 examples before. This one quiz number 3.
Okay, so
Example number 3.
okay.
This one example number 3. This one is number 3. Because this number 2, I switch it. Yeah, I switched this one number 2. Yeah, I changed the order in the last minute before the class.
Okay, so basically we're just gonna copy that down and then get as far as we can and then submit it.
Yes, yeah,
Okay,
that's exactly what I ask you to do.
okay.
And you will get rewarded. If you submit, you get rewarded, guys. I am really sorry to hold you more than this time. Any question, guys? Okay, I will update you for the lab for in Wednesday. So I will go today and see what the lab looks like and what we have and what we don't have, and then update you on Wednesday.
Professor,
Go ahead.
for the exam 2, I see that you just, when you said VS, you wrote VS is the same as IT. Or you wrote VS the same as IT in the answer.
For updating one,
Yeah.
I just did it this morning. Maybe
Solution,
you see it now.
but you wrote the same thing. See, as the answer, it's the same.
I'm sure I updated.
No.
I swear to God, I updated.
No, it's
I write
different.
with the yeah, I know what you're talking about, but
Okay.
wait a second.
And
Wait a
also,
second. No, it's not the same. No, not the same. No, I'm right. This one VC, this one. This one VS. This one VS of T. This one
okay, then the next one,
I of T.
but it's the same. You said equals, and it's the same thing.
Oh, maybe I didn't copy it right, but yes.
And
yes,
also,
you're
what
totally
about
right?
the current that's going through the resistor? Don't you have to take that into account as well?
Now wait a second. I wrote it down and maybe I forgot it I corrected here, and I take this one copy and paste. So it's supposed to be changed a little bit here. But let me confirm. Let me confirm it. Yes. I just forgot to fix it here. This one is 16T, and this one is 23. Okay, and this one's 16 minus 16. And this one is the 8. Thank you for that, really. I don't pay attention. I just copy it and paste it, and I forgot to edit it.
Yeah.
This one. Yeah, this one. Yeah.
What about the current that's going through the resistor? You have to, because you're asking for the total current.
That's the total current.
Capacitor and the resistor.
Which one?
So we have to take the total current through the capacitor and the resistor, right?
Okay. This is the total current. This is the current through the capacitor. This is the current through the resistors.
Yeah, I got a different answer. Can we work through it?
Absolutely. If you have time, totally fine.
But we have to submit it at 1. So what should I do first? We have to submit
this is the exam problem. Sorry guys, it's talking about the exam. So if you have nothing to do, you can leave. So you don't have to stay. I'm gonna work with the Majid right now. I worked on this example this morning, so let's see what do we have. Let's see, go back for the exam.
Professor, so should I turn in, what should I do for the quiz? Should I just meet
Majid right now
and come back after I do the quiz, or?
Okay, I already have, if you have time, I already 12:30, I have an office hour.
Yeah,
I will be in the Zoom if you have time. I can wait you the office hour from 12:30 to 1:30. So if you want to finish the quiz and then you enjoy it to the office hour Zoom meeting, it's totally fine to me. If you want to work with me right now and then I give you extension for the quiz exception, that's fine with me either.
Okay.
Whatever you feel comfortable with.
I'll just finish the quiz right now.
Okay, I will be open the second Zoom meeting for the office hour. You have to look at the meeting here and go to the office hour. I will be online until 1:30.
Okay.
Okay.
Same Zoom session.
No, this, you have to go to the Zoom meeting, and you find different. It's supposed to be the office hour. Call it office hour. Let me see. Here's the. Can you see it?
Okay.
Can you try it just before you leave? Supposed to be one at 12:30. You find it?
No. It just says what. It says now only the next meeting is only on Wednesday at 11 a.m.
Don't show to you any all Zoom meeting or something like this? These options?
No, it does not say any office hours.
Hmm.
Or do you want to just do it right now since everybody's here?
Absolutely, that's
yeah, I think-
4:35.
That's fine.
Okay, let's see what the exam.
Okay.
I can give extension all guys for about the quiz. Let's see for the exams. There we go.
Okay.
So asking for the determine I of t. Where is the I of t? It is the current goes through the capacitors and go through the resistors, right?
Yeah.
So now is the basically what do you have? That's what the starting point from here.
Okay.
So basically what do you have here is the I of t will be basically I through the capacitors plus I through the R.
Yeah.
I through what the current through the capacitors.
The current through the capacitor, I got
As a formula, call me as a formula.
as the formula 20.
Yes.
It'd be IC is equal to C dV over dt.
That's what I'm looking for. Plus, here's the VR, so we know Ohm's law. So we have resistors. I don't have the inductors. This
So-
is my IR of t, right? So now look at here. I have the capacitors and the inductors. They are in parallel. So basically, here is the V, the same volt across the capacitors, the same volt across the resistors.
Yeah.
So basically, what we have here, we have 5 dVs divided by dt plus Vs divided by 5 ohms. Am I right?
Yes.
That's it. You don't have to deal with anything else beside. You need to write down your Vs as a function with time. Once you find it, to find the current, you need to derivative and multiply by 5 plus Vs itself divide by 5.
Yes.
Okay.
I did that, but I got a different answer than you.
The way that you did, I follow it. Your step is right, but your problem is, I think this is the piece of advice. When you deal with the many numbers, you keep your final answer, the last part, to use the calculators.
I did.
But here you go, guys. Let's see it together and see if maybe I made mistake or not. But let's see what we end up with it. I did it in simple way, different that the way that you did.
Okay. Yeah, because I used point slope formula to find via t in that position. And then I took the derivative of it and multiplied it by 5 to find the current through the capacitor. And after that, I added that to.
Look, I think maybe the way that you did it with your analysis is kind of the confusing, but look, so I need to, that's what I did here. I type Vs of t as a function with time, right? So the first version I was expecting this one is 1, but this one is the 1.4. So we're looking for the equation, this one here. So here is the 0 for the t less than 0, sorry, less than 0.5. Then equation for this one, I don't know if he did it or not, but here is the m, the slope from that case. I have confirm it me, type it. So here is the 20 divided by 1.25. Am I right?
0.5.
Which one?
20 divided by 1.25 minus 5.
Minus, so,
Minus
this,
0.5.
so this one is the 0.75.
Yeah.
So basically 4 divided by 3. Am I right? So this is my slope, 80 divided by 3. Am I right?
Where did you get the 4 by 3 from?
So here is a 20 divided by 0.75, right? Am I right?
Yeah, that's 26.66.
Now I did it in a different way. I type it 2.75, 3 divided by 4.
Yeah, 26.66.
Okay, I will keep it. I keep it this one. 80 divided by 3. I don't need it with the calculations.
That is still same.
Still the same, yes. I'm sure the same. So now what because this line should be interaction somewhere, the negative value here. I need to find it.
Should be negative 13.3.
13.3. Let's give you my value and compare it with your values.
Okay.
I found it is 40 divided by 3.
That is same 13.3.
Okay, great. So this one, it should be, that's what I wrote in the second part. It should be m, which will be 80 divided by 3, t minus, according for my calculation, 40 divided by 3. This is for the range of the t larger than 0.5 and less than 1.25.
Yeah.
So similarly for the second part, what I found in my slope and my equations and compare them to your calculations. I found here's minus 80 divided by 3 t and plus 160 divided by 3. Compare those numbers. And this one, the second slope or the second line, this one here.
That is also what I got.
Okay, so you're totally right.
And then let's solve for what you said before. What is it
For
called?
I
I
of
current
t,
through the capacitance. So that's
I-
5 the
I
derivative.
of t, that's what, so C, which is supposed to be 5,
Yes.
d divided by dt, right? So let's find just divided by dt. Okay, 5.
That's
I
just
have 3 ranges, so I have just two values. So in this case, okay, we can do it in one shot. Here is the I of t.
Yeah, it's just
5 dv of t times I of t, oh sorry, plus sorry, v divided by 5. The same one. So let's consider about those one. So the first one I'm gonna derivative. So this one is gonna be cancelled, right?
Yeah.
And so it's t and type or divide by 5. This one,
Yeah.
the formula is right.
I got negative I got 133.33
Is
between 0.5 and 1.25.
is that one means type 400 divided by 3? Wait a second, not yet. So you have two partials. So the first part, C5 dv by dt. You agree with that?
Yeah, so 5
Okay.
times dt over 3.
That's the only thing we have. Plus I need to divide this one, the entire one by 3. So we end up with the 18 divided by 5. So it's 16 plus 16 divided by 3, t minus 8 divided by 3. And then I have this one with this one, I have to add them together. Let me see what I did here. I don't know what to type it here. Is it's 40, not 40, not 400. But I think it's 400. Since it is 5, yes. It is.
Not 400.
Okay, so this one, if you want to compare with your numbers, try to 392 divided by 3. How much you got? This is your number if you want to compare. And 16 divided by 3, this is my final number. It's correct.
$130.67.
It's not the same your number that you got.
It is the same number that I got.
Okay, so you are right. I accidentally divide this one by 5, not multiply by 5. This quantity by 5.
Yeah, that's why I was
Yep,
confused.
yep. That's the part. What about the second one? Is the same?
It's almost the same, but
Yes.
the one you wrote down is not right.
Yeah. So I accidentally divide by 5, not multiply by 5. So this is my, this is my bad rate. Yeah, you are right. Yeah, you are right. Yeah, I found my solutions here and it divide by 5, not multiply by 5. Yes.
Those are your final values for IFT.
IFT. That's I think.
What did you end up with?
Yeah, I will clean it up and upload it again. I will clean it
Okay.
up. This work.
I feel like I got that one right. It was the one I felt the best about.
I will double check. I will double check with the alls, not just you.
All right.
I
Yeah.
got 5t plus 130.67 for between 0.5 and 1.25.
I don't prefer to use the number. I will keep it like this, Reed. I'll keep it the fraction numbers. I don't want to use the calculator.
I did all mine in decimals, so it makes it a little harder to follow. but-
Yeah, exactly. That's why what happened with the Majid is hard to follow since with the decimals, really. But
Well,
okay,
I can
thank
follow
you.
him because he has decimals.
Usually I keep the decimal in the last part. If you will finalize my solution, then I will use the decimal form, really.
It'll
It's
make
easy.
it off by, it could make it off by a tenth or a few tenths, actually.
Okay, so I gotta.
That's why you should round to 4 digits, right?
Yeah, I should have, and I only was rounding to 2, and that's probably why. I like my final was 133.5, and I think it should have been closer to 0.3.
No, if it's close, so it's not gonna be
Yeah,
changed
it
there.
was
Yeah.
really
If you are close for the positive and negative, you are in the right sign, and the number they are close, usually consider it as a full mark.
Yeah.
Okay.
Method
Yeah.
should be correct and answer should be within the range, right?
Yes.
Sounds good.
Okay.
Okay, I will clean it up and I update it. I will update your score too, Majid.
Okay, sounds good.
Absolutely.
Thank
Do you
you.
need time for the quiz, guys? You need more time for a quiz, or you can
you-
finish it in half an hour.
Are you gonna check everyone's?
Yes, I do.
solution?
Yes, I
Okay.
have to. Yes, I
I just
have
want
to.
to make sure mine gets checked.
No, I have to. Yes. Baxter, I think you get a good score, right? Didn't you missed 2 points for on this one, right?
Yeah, something like that. But like,
Yeah, something like that. So I will double check, but I think I checked it this morning before before the class. I don't see any change really, but I will double check again.
okay, because I think reworking it, I got the same numbers that you just talked about in class, or like right now. So
Okay.
I think it should.
Definitely, I will double check with the all students, not just you. All students, I will get back and check again.
Okay, thank you very much.
Absolutely.
So, Professor, do you want me to convert it back into fraction?
No, you don't have to do nothing. You get the full mark for this question.
Okay.
Yes.
All right, sounds good. So when should I submit the quiz? When should we submit the quiz?
Yes, you can submit the quiz if you have to work on for half an hour. I think I set it to the 12 for 1 o'clock. I think if I remember correctly, really. Let me double check.
105.
105. You can finish it.
Is it enough time? What do you think?
I think so. If you do, you have screenshot from the last slide that we did.
Yeah, I took a screenshot of it.
Yeah. So if you get this one, so your mission to find B and C and A.
I'm just gonna do my best and turn it in at 1. So
Yes. Okay. Good. Do your
Thanks.
best.
Okay. Sounds good. Thank you, Professor.
Absolutely. Any other question?
No, that's it.
Well,
Okay.
yeah, thanks.
Have a great day, guys.
Yeah, bye.
Let's open my Zoom session for the second class.